Hello and welcome. In this video, I explain how you can calculate descriptive statistics of a sample of data. Among others, we explain how to compute the sample mean and variance. On this sheet, you see a sample of 30 female students and their respective heights. Based on the sample of 30, we want to get an idea about the height of female students in our region, which represents the population. We want to compute some descriptive data to have a first impression of the underlying distribution of the variable height. First of all, we start by computing the number of observations, as we will need this in the sequel. To do so, we type equals count of the height values in cells C3 till C32. Next, we will compute the mean value of the sample. To do that, we type equals average of the sample located in cells C3 till C32. Next to our computation using the Excel function, we will check if the value is as we expect. The mean value of our sample is defined as the sum of all observations divided by the number of observations. To compute this, we type equals sum of cells C3 till C32, the sample, and then divide by cell H3 that contains the number of observations. As you can see, the numbers match perfectly. The next element of our descriptive data is a sample variance. Again, we start by computing this using an Excel function. We type equals var. A lot of possibilities are available to compute the variance. First option is VAR.P, which calculates the variance based on the entire population. That's not what we need since we do not have the data of the entire population, but only of a sample. The var.s function below estimates the variance based on a sample. Remark that this function ignores logical values and text in the sample. We have a sample without text or logical values, so this is the function we need. Note that when you have a sample including text or logical values, you can use the var.a function instead. Let's double click on the var.s function. We are looking for the variance of the height values, so we enter the range C3 to C32 as argument. Now we verify if the figure is what we expect. Recall that the population's variance is defined as the expected value of the squared deviation of a random variable from its mean. To compute that, you take the sum of the squared deviations from each observation from the mean and divide this by the number of observations. Here we calculate the variance of a sample rather than the entire population. To take this into account, we divide the sum of squared deviations by the number of observations minus 1. This makes the resulting estimator unbiased, which means that the expected value of the estimator is equal to its population parameter. A characteristic that makes sure that the statistic neither over nor underestimates the population parameter and which is greatly appreciated in statistics. Let's make our calculations for the sample variance now. Here we will take a step-by-step approach using some help values. We start by computing the differences between the observations and the mean value. So we navigate to cell D3 where we type equals C3 minus the mean value in cell H4, which we will pin using the F4 button. Then we drag this down by navigating back to cell D3 and double-clicking on the square in the right bottom corner. In the second step, we square these values. We click on cell E3, type equals D3 to the power 2, and drag this down. Using these values, we will now compute the variance. We go to cell I5 and type equals sum of the range E3 to E32 and divide this by the number of observations in cell H3 minus 1. We enter and see the same figure appear as computed using the Excel var.s function. Finally, we compute the sample standard deviation, which should be equal to the square root of the variance. We navigate to cell H6 and type stdef. As for the variance, you have quite a lot of options as well. We work with a sample, so again, go for the stdef.s function. We then insert the range C to C32 and press enter. To check this, we go to cell I6 and type equals S²T of I5. We press enter and note that the figure matches the standard deviation computed with the Excel function. Based on this descriptive data, we now have an idea about the distribution of height of female students in our region. On average, they measure 171 centimeters with a standard deviation of about 8 centimeters. If we assume the variable height is normally distributed, we can say that about 68% of the female students in our region measures between 163 and 179, which is 1 standard deviation away from the mean. About 95% lies between 155 and 187, which is 2 standard deviations away from the mean. And finally, about 99.7% lies between 147 and 195, which is 3 standard deviations away from the mean. This concludes our tutorial on sample mean and variance in Excel. Questions or remarks are always welcome in the comments below. Subscribing would be awesome. Thanks for watching, and I'll see you in the next one.